Hi, welcome back in the next episode of YaSBoot implementation. In previous episode we created hardware abstraction layer, we added some system level testing, so now it's time to add some code coverage measurements, to add some static analyzers and automate everything with continuous integration. And as always I will show you how I did it, so you can easily integrate into your project if you are using GitHub. But if you are not using GitHub, I'm pretty sure that other hosting services has similar functionality, so let's get started. At the end of that episode we want to achieve everything green, like on that slide. For my continuous integration I used Docker with GitHub Actions and also with Sonar Cloud. Sonar Cloud is used as static analyzer, but also it has nice view about code coverage. I'm using GitHub Actions together with Docker because otherwise each workflow must fetch tool chain by its own, and this increases time significantly. After that, let's create our image and push it to GitHub container registry. Going further, I created workflow script that fetches our new Docker container, configures CMake and executes system tests. Let's push it to the repository and see the result. On the repository page we can see that our GitHub action was executed, but immediately failed. And to do it we have to open our organization website in GitHub with packages and container and settings for that particular container, and allow some repositories to access it. Let's restart our test, and now it failed but with different error. So for sure container was fetched, and let's fix that issue. And boom, we have first success! Let's add also target compilation for verification. Previously we added system level testing to our continuous integration, and now we will compile YaSBoot for MSPC, and in the future for other hardwares as well. So we have to extend our Docker to contain ARM toolchain. And let's build our new Docker image. After that, let's create new workflow script that will compile for MSPC. And we can see that I created matrix build, so in the future I will be able to compile not only for MSPC but also for other targets. And we can see on GitHub that MSPC target was built successfully. Now it's time to add some sanitizers, to add some code coverage, and also to integrate with Sonar Cloud. I'm using external project called CMake Utils, and it contains some CMake functions that generates targets that will contain necessary flags. After that I faced issue that code coverage artifacts were not collected, and it was because our YaSBoot application never finishes, so it's always killed by system level test. And yeah, now files are captured. Let's open Sonar Cloud and create new project here. If you have Sonar Cloud integrated with GitHub, you can automatically create a project. After that there is manual how to use that tool. So basically we have to pass some token that will allow Sonar Cloud to access GitHub. And there is example of workflow how to use it. But I'm going to use old way that I have in another project. So let's copy that Sonar Cloud command, pass necessary variables. The major one is to pass compile commands because Sonar Cloud is using them. Firstly I added Sonar version in my workflow script, but after that I realized that it's better to place it in Docker. So let's modify Docker file. If you faced an issue in Docker while installing software, from repository that uses interactive configuration, you have to disable it. And let's verify that our continuous integration is working. In the meantime, let's fix name for target because I've copied it wrongly. Sonar scanner were executed, but it failed because it does not support C++23, so let's change it to C++20. I totally not spent a couple of hours to debugging that issue. And here is the solution. Fine, tests are working. Let's check out how it looks like on Sonar Cloud. And in the summary, we are able to see that we have some issues reported by Sonar Cloud, but we don't have coverage report. And this is probably because I implemented this hack with returning from main. Now it's time to implement it correctly. And let's proceed with fix for code coverage. So I'm going to add new functionality to my hardware abstraction layer that will decide if our application should exit or not. For example, for MSPC we will never return from YASBoot. But on host we should return. And I decided to react to interrupt signal from system. So let's add signal handling in hardware abstraction layer for host. After delivering to repository, the workflow were started and finished, and after that we can check on Sonar Cloud that now our coverage is measured and is probably measured correctly. In the same manner, I added also other tools like ClankTidy, starting from creation of ClankTidy file. That file contains checks that I enabled for my project. Also, I had to include new function inside my CMake to configure ClankTidy. For ClankTidy, we have to do additional thing to filter out compile commands from files that we are not interested in. For example, to remove files from external libraries. And for that, I'm using compile commands package from Python pip. Let's also check workflow script. It's exactly same like the previous ones, but only uses additional flag that enables ClankTidy. And I also added workflow file for sanitizers. That one is more interesting because I'm using Matrix that enables every sanitizer that I'm supporting. If you are not using continuous integration, I recommend to use it. I hope you enjoyed that video. It was the last thing that I had to create in my YASBoot project environment. And now I'm ready to code, so in the next episode we will be programming. See you in 2 weeks. And leave like if it was interesting for you.